Dear students, in the last video, we discussed about image segmentation based on discontinuity. We have one more approach for image segmentation, which is based on similarity of the pixels. The pixels might be similar in some criteria. Based on criteria, again, it is possible to carry out image segmentation. So under this heading, we are going to discuss three important concepts called thresholding, region growing, region splitting, and merging. These are again the techniques which can be used for segmentation of objects of the image. So first, we are going to start with thresholding. So actually, thresholding means we are going to detect the required objects based on some similarity. Say, for example, you assume that you have an image f of xy, so that you can go on testing each and every pixel. If the intensity of a particular pixel, if it is greater than the threshold value, you can assume that particular pixel belongs to an object, otherwise it belongs to a background. This is one of the example. The idea is like this. What you can do is, you check each and every pixel of the image, say f of xy, if it is greater than the threshold value, you assume that pixel belongs to the object. Otherwise, that pixel belongs to the background. Say, for example, you assume that you have a shaded circle with white background. In that case, you go on check, you go on testing each and every pixel, whether it is a black color or white color. So if it is black color, you can assume that pixel belongs to an object point, or it is the object which is to be detected. Otherwise, that pixel can be assumed as the background pixel. So this concept we can represent by using this equation g of xy equal to 1 if f of xy is greater than t, where t is the threshold value. This threshold value can be selected based on the particular application. So if it is greater than threshold value, you assume that point or pixel belongs to the object. Otherwise, that pixel or point belongs to the background. Here T, we call it as global thresholding value. Okay, here we have binary thresholding. However, it is possible to have multiple thresholding also. So in case of multiple thresholding, we can have the mathematical representation of the equation as g of xy equal to a if f of xy is greater than, say, t2. So you can have multiple thresholding values. If f of xy is greater than t2, you can assume that pixel belongs to an object a, or if the pixel value is between t1 and t2, you can assume that pixel belongs to the object b. Otherwise, if f of xy is less than or equal to t1, you can assume that pixel belongs to the object c. So whenever you have multiple objects of interest which are to be segmented from the image, there you can use such equations. So these thresholding values need to be chosen based on some experimentation. This concept we call it as thresholding. Here we discuss about the different types of thresholding. So basically, thresholding, it is a function of coordinate point x comma y, and it can be represented as th. Th means a thresholding concept. Thresholding, it is the function of four different values: x, x, y, f of xy, p of xy. Here, x and y, they are the coordinate points. F of xy, it indicates the intensity of the pixel, and p of xy, it indicates the different properties of the pixels. P of xy, it may be indicating contrast of the pixel, it may be indicating intensity, or it may be indicating color, like that. It may represent any local properties of the pixels. So here we have three different types of thresholding. First, we have global thresholding. It only depends on gray levels of the image. It depends only on intensity values of the image f of x comma y. Then we have called local thresholding. Local thresholding, it depends on gray levels of an image along with some local properties. So actually this local thresholding, it is concerned with these two parameters. One is f of xy, which is the gray level values of the image, and p of xy, which are representing the local properties of the image. So local thresholding, remember it depends on gray levels of the image along with some local properties. Then we have adaptive thresholding. The adaptive thresholding depends on gray levels of the image, that is f of xy, some local properties p of xy, also on the coordinate values of the pixels, say x and y. So global thresholding depends on only gray levels of the image. Local thresholding, it depends on f of xy and p of xy. However, adaptive thresholding, it depends on all the four values x, y, that is coordinate values, also depends on gray level values along with the local properties of the image or pixels. Okay, here we are going to discuss about the steps employed in basic global thresholding. We have a method called basic global thresholding. This method includes five important steps. It's like an algorithm. So in this algorithm, for thresholding any of the image for segmentation purpose, we employ these steps. The first step is we select an initial estimate for global threshold T. By some experimentation or looking at the image first time, we can select an initial estimate T as the global threshold. That is the first step. Then based on this T value, we are going to segment the pixels of the image with respect to T. So it will produce two group of pixels. Say G1 consisting of all the pixels with intensity values greater than T, and G2 consisting of pixels with values less than or equal to T. In the second step, we are going to segment the image using the threshold value set T. It will produce two group of pixels. Say G1 consisting of all the pixels with intensity values greater than T, and G2 consisting of all the pixels with values less than or equal to T. In the third step, we are going to compute the average of pixels in the group G1 and average of the pixels in the group G2. Let M1 and M2, they are average of pixels in the group G1 and group G2 respectively. Then we compute a new threshold value T by taking the average of M1 and M2. That is, we compute T as new threshold value T as 1 by 2 in bracket M1 plus M2, where M1 is average of the gray level values of the pixels in the group G1 and M2 is the average of pixels which exist in the group G2. Then we repeat the steps from 2 to 4 until the difference between the values of t in the successive iterations is less than a predefined parameter delta t. We repeat the steps 2 to 4 as long as the value of t in the successive iterations is less than or equal to the predefined parameter delta t. This method we call it as global thresholding. This global thresholding can be easily achieved in the MATLAB. In the MATLAB, directly we have a function to have global thresholding of the image. The next, here we have an example of global thresholding. So here we have a noisy fingerprint. We have a noisy fingerprint. It includes some background with gray color, and also it has the fingerprint image. So here, first they have plotted the histogram. Histogram they have plotted. Figure B shows histogram of this image. Then in the figure C, we have segmented result using global threshold. So this is the result we get after applying the thresholding concept. So this is an example of global thresholding. The next, we are going to discuss about the topic called region-based segmentation. So again, in region-based segmentation, first we have the algorithm region growing. So region growing algorithm is one of the simplest algorithm which can be used for segmenting the different objects of the image. The concept is like this. Here, first we choose an arbitrary pixel as the seed pixel, and we compare the properties of this pixel with neighborhood pixels. The idea is like this. We start by choosing an arbitrary seed pixel and we compare its properties with neighborhood pixels. The region is grown from the seed pixel by adding neighboring pixels only if those neighboring pixels satisfy predefined criteria. We are going to set some criteria for adding the neighboring pixels into a group. Only if that criteria is satisfied, the neighboring pixels they are added with the seed pixel. The idea is like this. The region is grown, means that object is grown from the seed pixel by adding neighboring pixels only if they satisfy the predefined criteria. When the growth of one region stops, we choose another seed pixel and again we start the process. We start from the seed pixel. Once the growth in all the directions will stop, we choose another seed pixel and again we start the process. We repeat the entire procedure until all the possible regions are found. So this is a particular concept we use in region-based segmentation based on region growing. The total concept is like this. We select some seed pixel. From the seed pixel, we go on adding the neighboring pixels only if those neighboring pixels satisfy some criteria. When the growth of the region stops in all the directions, we choose another seed pixel and again we go on repeating the process. The entire process is repeated until all the possible regions are found. This is about region growing. So the region-based segmentation, it can be defined with this mathematical equation. If this is one of the example, here criteria they have taken is the intensity values. If the difference between intensity of the seed pixel and the neighboring pixel, if it is less than or equal to t, that is some threshold value. If it is less than or equal to threshold value, then it is considered into the same region. Otherwise, it is not considered into that region. Here, the idea is like this. If the absolute difference of the intensities between the seed and the neighboring pixel at location x comma y, if it is less than or equal to t, we assume that that pixel belongs to the same region. Otherwise, we assume that that pixel will not belong to that particular region. This is the concept we can employ in many of the real-time applications. Say, for example, you assume that you have apples, you have just assumed that a group of fruits. From the fruits, you want to detect only apples. So if you study the color of the apples, it will be in the range of red color, red, orange, and so on. Okay. So what you can do is you can go on checking each and every pixels of that image, and if the pixel value belongs to the range of red color, you can assume that all those pixels, they belong to the Apple object. So like that, we can employ region growing or region-based segmentation in many of the applications. But while applying this concept, you require to study the application or domain in depth. Then you can easily apply such concepts. Okay, students, I'm going to stop this video. In the next video, we discuss an example of region-based segmentation. Along with that, we also discuss region splitting and segmentation. Based on region splitting and merging, we have one more concept of region-based segmentation that we discuss in the next video. Thank you very much. Thank you all.